Hello there, and welcome to another Science Saturday. I'm your host, Noah Mugen. Oh, I hope you've had a nice, relaxing November and a happy Thanksgiving. And we're glad to have you back. Today, we're going to be going over the science of static electricity. And I'm going to quickly cover the materials that we'll be using in today's experiments. Now, if you don't have everything, don't worry, as it's easy to follow along. Today, you'll need balloons, some sort of woolen fabric, like I have a blanket right here, string, and a partner. It's finally November again, a full year after I started making these videos. And with the passing of Halloween last month, I'm sure you've all seen the Christmas lights that have sprung up everywhere. They really do look nice, brightening up our dark streets and making businesses look that much more cozy. But how exactly do they work? I'm sure that you've heard that lights, like the types used in LEDs for Christmas lights, need electricity. But what exactly is electricity, and why does that make light? Well, it's a pretty complex topic, and today we're going to be going over the basics of electricity, called static electricity. Have you ever been wearing your cozy wool socks around in your carpet and suddenly get shocked when you touch the door? Well, that's actually static electricity in action. As we've covered before, anything with mass, or in other words, any object, contains atoms. Atoms are composed of three subatomic particles: protons, neutrons, and electrons. Protons and neutrons exist in the center of an atom, while electrons go around the outside of it. Protons have a positive charge. Neutrons have a neutral charge, or no charge, and electrons have a negative charge. Now, protons and neutrons are held in place in the center of the atom and can't really move easily. However, electrons are able to jump between atoms as they're moving around the edge, meaning that an atom can end up with more or less electrons than it usually has. When an atom has equal numbers of protons and electrons, then they cancel each other out, and it's neutral, or has no charge. However, a substance can gain electrons or lose electrons from its environment, which will lead to a charge. If a substance has more electrons than usual, the negative charge from the electrons overpowers the positive charge from the protons, and it's said to have a negative overall charge. Likewise, if a substance loses electrons, then it has more protons than it has electrons, and so it's said to have a positive charge. When you rub two objects together, electrons can flow between the objects and in the direction of the object, which has a larger pull on the electrons. One way to show this is with a balloon and a sort of wool material. I have a blanket. When I rub the blanket on the balloon has a stronger pull on electrons, so electrons flow from the blanket into the balloon. If you take them apart, there are now more electrons than usual in the balloon. That means that this has a negative overall charge, while the blanket has less electrons than usual since they flowed out of it. This means that this blanket has an overall positive charge. And different charges will react in interesting ways. Opposite charges, so a positive charge and a negative charge, will actually attract each other and pull on each other. While if you have the same charge, whether it be a positive charge and a positive charge, or a negative charge and a negative charge, they will repel each other and push each other away. Now, let's show all of this in action. For this first experiment, you're going to need a balloon and a partner. First, blow the balloon up. Now, have your partner rub the balloon on your hair. As the balloon is rubbing on my hair, electrons are going from my hair into the balloon. Now, take the balloon off. Electrons have gone into the balloon, leaving it with a negative charge. Electrons have left my hair, so now my hair has a positive charge. Now, if your partner puts the balloon over your hair, just close to it, you'll see that your hair is attracted to the balloon. Mine is lifting up, and it's sticking to and going towards the balloon. That's because, well, the balloon has a negative charge and my hair is a positive charge, opposites attract, and so they go together. For this next experiment, you're going to need 2 more balloons, the woolen substance, string, and a partner again. First, blow the balloons up. Now, tie a string around the end of each of them. Now that your balloons both have a string on them, you're going to rub their entire surface with the wool. Make sure that you rub the entire thing so that the entire surface is made negative. Remember, as I'm rubbing this balloon with the wool, electrons are going from the wool into the balloon, leaving the balloon negatively charged, while the blanket is now positively charged. It's important that you rub the entire surface of the balloon so that the entire surface becomes negatively charged. I'm going to explain why this is important in a minute. Now that both of your balloons are negatively charged, try and bring them closer together. Do you see how, as I bring this balloon closer to this one, a specific spot on the balloon keeps turning to meet it? That means that that spot isn't as negatively charged as the rest of it, so that when this balloon comes closer, that spot isn't repelled away. We're going to bring these apart and then rub each of them again with the wool to make sure that the entire surface is negatively charged. Now, try bringing the balloons closer together again. Even though I'm bringing the string over, the balloons still don't want to touch. It's angled away. This is because both the balloons are negatively charged. See this space right here? If they were just neutral, they'd be touching right now. But because they're negatively charged, they're both negatively charged. They have the same charge. And like charges repel. See? Bring this closer. It's pushing this balloon away. This all explains why you feel that shock after rubbing your feet on carpet. Electrons flow from the carpet and into your body. And when you touch the doorknob, the electrons suddenly rush out and generate a shock. Well, that was static electricity, the basics of electricity. I hope you had fun. I certainly did. Stay safe, have fun, and we'll see you next month. Bye-bye.